Hello, everyone. Thank you for attending our webinar here today. My name is Matt Filkins. I am the owner of Reality 3D, and along with me is my business partner, Stuart Bell. He is also our head applications engineer, and we're also going to have Jeff Moody, an applications engineer from Geomagic Software. Reality 3D is a reseller of Artec 3D scanners and Geomagic software. We're located in Denver and have about 12 years of combined experience in selling Artec and Geomagic products. We are also what's known as a gold certified reseller from Artec, one of a handful in the country. Basically, Artec designates us as having exceptional product knowledge of their scanners. All right, today we are going to be highlighting the brand new Artec Leo in conjunction with Geomagic software products Design X for reverse engineering and Control X for inspection, and try and tackle a real-world scenario and application. We're going to be scanning a Kayak with the Leo, and then modeling with Design X, and then comparing the two data sets with Control X. Keep in mind that this is a Kayak, but the scanners really don't care what they're scanning, so this could be a small mechanical part or a vehicle. It really doesn't matter. Here's a quick photo of the Leo. The Leo is Artec's first non-tethered 3D scanner. You don't need to have a laptop attached to it to do the scanning due to its onboard processing power. It has a very large field of view and extremely fast frame rate, which allows it to scan items the size of about a softball up to a box truck very quickly. Stu's going to do a deep dive into the scanner, so I don't want to give too much away as we go. After we reverse engineer the Kayak in Design X, we are going to be moving over to inspecting it with the recently updated Control X. We have a rep from Geomagic, so I'm going to let him do a deep dive into it with its recent features and benefits. So I'm going to kick it over to Stu here in a second, but feel free to ask any questions during the demo. There's a chat box in the GoToMeeting toolbar. We'll try and address everyone's questions after the demo. So I'm going to make Stu the presenter here real quick, and we'll start some scanning.
Thanks, Matt. I'll get this switched over here. Give me just. We're going to dive right into watching the scanning process. This is pre-recorded. We did this out at the 3D Systems facilities here in Denver. You can see me just scanning the Kayak here. We sped this up to save us some time. So keep our presentation short and sweet. As Matt said, this is the Artec Leo. It is a line of sight scanner, as with all the Artec scanners. If you notice down in the right-hand corner, you'll see my data coming in on a laptop screen, so you can see what I see as I'm scanning. The Leo is a brand new technology. It's a sub-visible light structured light scanner. It does a really good job scanning in very quickly. Full control touch panel on the back. If you can watch me using the control panel to manipulate and verify my data as I go through. We'll make the transition here to just a couple seconds into processing the data. So we've made the leap into Artec Studio 14. We're going to go through a workflow here that is basically cleaning up the data, aligning the data, running it through an algorithm, and then generating a mesh out of that. So we'll start by cleaning up the data here. One of the reasons we chose Artec when we started our business here was its powerful and easy to use editing tools. The technology, the scanner technology, was a big factor as well, but the user interface has really been nothing but impressive with the Artec setup. So I'm just creating a cutoff plane here, highlighted the table. It's going to basically eliminate everything that's below that little, below the plane. I can adjust the height of the plane, move that up a little bit. And when I hit erase, it eliminates that data for me. We'll rinse and repeat through the other 4 data sets. We'll use one of our other tools here, the 2D select tool. This is basically a paintbrush tool. Allows me to just paint on all the data underneath there and erase it very quickly. On to our third data set. I'm going to try the cutoff plane again here, see what we get. If you notice, it's actually going to clip the end of my kayak, and I don't necessarily want to lose that data, so I'm going to go ahead and try a different methodology. We're going to try base select instead. Just deselect that. Base select basically, it takes and it tries to establish tangency by looking at everything that's close to that surface as I paint on it. Also highlighting the end of my kayak, so I'm just going to grab my 2D select tool and do this a little bit more manually. All right, verified, see if pick up any of these extra areas, paint from this side as well. Last little section. If we like what we see, we'll hit the erase key. And last data set. Oh, a little bit here, we'll get rid of that. And now, if we like what we see, we'll move on to the last data set. Same thing, I have this hanging over the edge, so I'm just going to stick with my 2D select tool. There's also a box select and a lasso select. I'm not going to use those because I generally prefer the 2D selection, the paint tool. You can see I painted a little onto my model. I don't want to lose that data. So I'm just going to adjust the size of my brush and just deselect that manually. Save myself that data. There's that. So now that's our first step. We've cleaned up the data, pick up a little bit of any extras in the anything left from the table. We're going to move on to the align tool here. We'll exit out of the eraser tool and take just a moment here. It'll load these scans up for me. Highlight all the scans I want to align, and we'll go into the align tool. And basically what I'm going to do is I'm going to take the first scan I did and treat it as a keystone scan. I'm going to flip everything around and align it all to it. I can do that by auto alignment or by manual. I'm going to show the manual alignment to show how quick it can be to do things manually within Artec here. So in here, the blue scan is our keystone scan, and anything that's green is going to be the aligning to. I get it flipped around in orientation. Get myself in, and then I'm going to add some control nodes. I do that just by clicking on the mesh in overlapping data, where data is overlapping. I want at least 3. For something like this that's a little more symmetrical, I might go 4. Align markers, that looks pretty close, so we'll hit align. If you watch the animation, you can see it does a feature recognition and pulls it in. And we'll just rinse, repeat, and go through the next data sets here. Get it close. Add my control nodes. With the control nodes, basically what I'm doing is controlling along my 6 degrees of freedom by telling the software that these are overlapping features. We won't try to flip it around or try to find patches that look really similar but are actually on opposite sides of the subject. We'll hit align again. And our last data set. Auto alignment does a pretty good job. I didn't test it on here. It can take a little bit more time just to run it, but it's an automated process, so it's something where you can set it and forget it. See, I actually move my my control nodes like I just did here when I misclick, or if I click on a place where there's not overlapping geometry. So the makes it pretty quick and easy to do the alignment. If we like how it looks looks pretty good. We don't see anything jutting out. We'll just hit apply. Now we're going to move to what's called global registration. There are 3 levels of registrations: during scanning, during the alignment here, and then what we're going to do here, which is global registration. Just double check and make sure my settings are correct. What this does is going to take and look at all the frames. Each scan consists of a certain number of frames, and it's going to look at all of them, and it's going to bring them all into the same coordinate system. And you'll see there's a slight color shift there now. Instead of being several different colors, all the different colors of my scans are now all integrated together and gives it a nice multicolor piece, sort of like it's been splattered with paint. I'm going to do a sharp fusion next, but before I do that, I'm going to go through. Looks like I have a few failed frames. I'm going to pull those out of the scan so they don't affect my end result. I'm now editing each scan on a per frame basis. You can see each scan consists of a certain number of frames. I'm just going through and finding the ones that the software is marked as having failed the registration process. I don't delete those. You'll see there are also an error number. That error number I want to keep below 1. I'm looking for basically a 0.3 to a 0.9, depending on the size of my object. This is a pretty large object with a lot of smooth surfaces, so a 0.9 is actually a pretty good scan for me. You can see that's my worst area is a 0.9. So once we like that, I'm going to tell it I want this to be watertight. Just do a quick inspection, and we should hit apply. And now we have a mesh. I'll run a small object filter just to get rid of any extra noise. And with that, I'm going to pass this over to Jeff. Give Jeff just a second to get caught up.
Thanks, Stuart. Hello, everyone. Once again, my name is Jeff Moody. I'm an applications engineer with 3D Systems Software. And today we're going to be talking about reverse engineering using surface modeling techniques, taking that solid model into Control X to do an inspection on a secondary part. Now, the first portion of my demonstration has been pre-recorded because it did actually take quite a while to reverse engineer this kayak. So let's go ahead and get started. Here we can see multiple different colors on the mesh. Each color represents a different region. Design X generates these regions by doing a curvature-based analysis on the mesh to create basic geometry shapes. Once these regions are created, I can then use them to create fitted surfaces. These surfaces fit to the colored regions I select, allowing me to create the flowing contours of the kayak. The surfaces then need to be trimmed back, and to do that, I use 2 different methods. The first method is, using the contoured surfaces themselves, trim them in place. Then, using the sewing option, I stitch all of the surfaces together to make one single surface. The second method is, create a sketch plane, then create a sketch to extrude to make a cutting plane. Oftentimes, using this second method, the surfaces won't be touching each other. To connect them and to sew them all together, I use a surface loft. Once the 2 surfaces are lofted together, they then become one single surface. These processes are repeated over and over again along each individual surface. In some instances, I need to be a little bit more diligent about how I'm creating the surface. In those cases, I can use a 3D mesh sketch, which will apply a spline along the surface of the mesh, which I can then use as a guide curve to create a loft. We have a specific tool in Design X called Loft Wizard, which allows me to create lofts very quickly and efficiently along that mesh contour. All of these surfacing techniques, creating regions, applying surfaces to those regions, trimming surfaces, whether it be using themselves or sketches, creating region lofts, or lofts using guide curves, will be repeated throughout this mesh model until the result is a fully finished solid body. Once we have the solid model of the kayak created, we can then bring it into Geomagic Control X to use it to inspect all other scans of the same kayak model. That solid model looks something like this. So now let's get into Geomagic Control X. First, I'm going to start off by talking about the UI of the software. Then we'll get into the inspection routine itself. Then we'll finish up by creating a report to send it off to whoever needs to see it. First, let's talk about the user interface. On the left-hand side here, we have a result data. You can think of this as the inspection routine itself, and each one of these line items here is something that needs to be populated. Up on top is the tool ribbons layout. Control X has a large tool set for each individual operation in an inspection routine. Down on the bottom is a tabular view that displays statistical information about the things that are selected, about the processes that we're doing. On the right-hand side is our Display tab and our Properties tab. So let's go ahead and import our newly created CAD file. And we can see that it automatically populates under the measured data. That's because anything that is mesh automatically populates here. Anything that is CAD will populate in the reference data. Our next job is to get these two over the top of each other. And we need to do two types of alignment. In most cases, you start out by doing an initial alignment. This takes a look in a large area and tries to find two objects to put over the top of each other. Next, we need to do a secondary alignment to really hone in our alignment. We have several different types, including Best Fit, RPS, Datum, 321, Transform, and several others. In this case, I'm going to be using the Best Fit alignment. In my Best Fit alignment, I have a couple things that I've already set up. My sampling ratio is set at 95%. That's telling the software to take a look at 95% of all the points in that mesh and then align them as best as possible to the CAD. I also have told the software to try 30 times to get this optimum alignment. So now I'll come up to the Compare tab and select 3D Compare. I'll go to the next stage. This is where I can adjust my color bar or my color overlay. Here on the right hand side we have a color bar, and this have a darker color showing the histogram of all the points in the scan. So we can see that it's outside of our range, so I need to adjust my color bar range. To do that, I'll set my max range to 5 millimeters. I'll also add in a specific tolerance. And now we can see that histogram is a little bit tighter because our range is opened up, and now a majority of the points are inside my tolerance zone. Anywhere we see this gray color, that means that there is no mesh to compare against the CAD. Anywhere we see this red color, the mesh is actually outside of the CAD. Anywhere we see this dark blue color or light blue colors, the mesh is actually inside the CAD. I'll go ahead and say OK to this 3D compare. And maybe I'll take a cross section of this specific area so I can really diagnose what's going on. If I had a base plane ready to go, I could select that here, but I'm going to go ahead and use the X plane in the global origin. I can use these nodes to drag my plane down and hide the information that I don't need to see, making it easier for the person seeing the report to understand what's going on. I'll go to the next stage, which will bring me into a 2D mode. And again, I need to adjust my color bar range to 5 millimeters and set my specific tolerance. I can then use local average tagging to give me the highest point out and the lowest point. And I'll go ahead and adjust those here. I'll then say OK and exit out of the 2D mode. We can see over here on the left-hand side in the analysis bucket under the compare group, I have a 3D compare created and I have a 2D compare created. Next, let's go ahead and create some comparison points. Up in the compare group, I'll select comparison point, which then allows me to create several different points. I don't have anything to define along this surface, so the first thing I'm going to do is I'm going to come up to the Curves tool, select Curve, select Spline, and then I'm going to set a spline right in the middle of this face. That looks pretty good. I'll then exit out, come back to the Compare tab, select Comparison Points again, select Along the Curve, and then just choose my seed point here. I'll change my number of instances to 5, and I'll tell it to do equal spacing. I'll go ahead and say OK there. I'll hide my curve over in the result data. And now I have 5 different points that I can see the deviation in. I'll take a look at this picture. I might want to adjust this picture because it's not really telling me any useful information there. So I'm going to go ahead and choose the Reassign viewpoint here. Might need to zoom out a bit. There we go, that looks good. I'll go ahead and turn those off. The last thing that I want to do is add a GD&T callout. And here I want to add in a surface profile. I'm going to go ahead and set this. Instead of using a datum reference frame, I'm going to use my current alignment. And I'll say OK. Now, the last thing I need to do is create a report. And to do that, I went back to the Home tab. Under the Report group, I'm going to click Generate Report. And in here is all of the things that we've created so far. And we haven't really created very much, but if we didn't want to have something, say the initial alignment, we could use these arrows to put it back into our source entities and remove it from our selected entities. This way, the people viewing the report only get the important information that they need to see. I'm also going to add in a 3D PDF, and then I'll add in a couple things down here. I'll click Generate, and that'll bring me into the report template. Here we can see a couple things. We can save our report out in 3 different formats: PDF, PowerPoint, and Excel. We can also save out an XML format for trend analysis. On the right hand side here, everything can be modified just by clicking on it and selecting Edit. When we scroll down, the first thing we come across is the 3D PDF. It doesn't save out as a 3D object until it's saved out as a PDF. Here we see the CAD data or the reference data, the measure data or the scan data, the best fit alignment with a histogram of the alignment, and all the statistical information. The next thing we come across is the 3D comparison with the histogram of the comparison and all the statistical information. Now, unfortunately, this picture wasn't automatically taken in the correct orientation, so I need to modify that. Control X makes it easy to do. All you have to do is go back into the program itself, highlight the 3D comparison, select Apply Viewpoint. This will take me back to when the picture was taken. I can adjust it because I want to see this side, and then reassign the viewpoint. Once I've reassigned the viewpoint, I can then go back into the report template and select Rebuild. This will rebuild only this specific picture, which is nice for the customers because it saves time in processing. Again, here's my 2D layout, and it's kind of a mess. The tags are being intersected by the color bar, so I need to fix it. I'll go back into the 2D comparison, reassign that viewpoint, and adjust my tags. I'll then reassign the viewpoint again. I'll go back into the report and select Rebuild. This also gives us a picture of where the cross-section was taken, somewhere in the middle of the kayak. Also, since we have 2 comparison tags, this gives us a tabular view in the next page about those tags. Our comparison points are next, with all 5 comparison points, and the tabular view of those points. Last but not least is our single surface profile. And again, that picture can be changed, but it also gives us the tabular view of that surface profile. I'll go ahead and save it out as a PDF so that I can send it on to the person that needs to see it. And with that, I'll hand it back over to you guys. Thank you very much.
All right, thanks, Jeff. So that is our presentation. Let me show my screen here real quick. Give me 1 second here. We're going to open it. That was our presentation of the Artec Leo and Geomagic Control X and Design X. Now would be a good time for some questions. We are going to be sending out a recording of this in case you want to forward it on or look at it again. We're also going to get the inspection report from Geomagic and send that out to all of you, as well as spec data on the scanners and software. And we'll email that out to you probably early next week. So we did have some questions. Let's see here. Understand that the Leo was advertised with a lot higher specs than it actually built with in the end. Is this a hardware limitation? No, I believe that's a software limitation. There are some improvements that are scheduled for the next release of Artec Studio. I think Stu can address that here, though, a little bit more in depth for everyone.
Yeah, absolutely. Excuse me. The big one that we saw was the as advertised frame rate, which was originally advertised quite a bit higher than what we're seeing now. We usually see about 24 frames per second in terms of our sampling rate, and it was advertised much higher. I think up at one point is somewhere in the 80s potentially. This is subject to change. They're talking about releasing this, and that is a software limitation. They can't handle the throughput, not can't handle, but they're trying to build up so they can handle that level of throughput. Right now, what we've seen is the 24 frames per second actually generates pretty detailed models, and is in some ways a blessing that it's not sampling at quite that high of a rate, just because our models tend to be, data sets can be already nice and large. So I know that they are planning updates in the future, and the new releases, new patches to the scanner itself, as well as updates to the processing software Artec Studio. Looks like there's a follow-up question. Are the Leos being built to handle the higher frame rate per second software when it's available? Yes. To the best of our understanding, they are. They are capable of doing it. It's merely handling that much data as in a throughput. Beyond that, they don't share a lot of that background information with us, but our understanding is they are being built and should be able to handle that much higher frame rate once they are able to get it through the software side of things. Any other questions?
I have one here about pricing. So the Artec Leo is the newest scanner, but it's not actually the most expensive scanner from Artec. Basically, we're looking at about $25,800 for the scanner, and then you're going to need to purchase a license of Artec Studio. Currently, we're in version 14. That is $1,200 for an annual one-year subscription, or $2,800 for a lifetime license. With the subscription, the $1,200 model, you get all of the updates for a year. So if we go to Studio 15, you'll get that. And if you get a lifetime license, you will get all of the updates through that version. But then the updates stop at the end of when Artec switches to the new version. So it's kind of a whatever the customer prefers to do. I see that we do have a few professors in here with us today. Artec does like to support EDU, so there is a 10% discount for the scanner right off of the top, and then you get 20 free licenses of Studio, 2 years of free software updates, and a 2-year warranty on the scanner. So that is how they handle EDU. Stu, are you seeing any other questions? I'm having actually a problem looking at the questions.
I don't see any other ones. Let me double check and make sure I'm refreshed. I do see a question about availability on the Leo.
Okay, I can speak to that. So Artec really got released, I believe, in 2018, early 2018, and the first units really started shipping early this year, this summer. So they didn't really anticipate the demand for this scanner. So we are still looking at about a 3 to 6 month wait time once you place your order. And how Artec handles that is you do a 50% down payment to get you in the queue, and then the final payment is due when the scanner actually ships. We are seeing time slightly improved over where they were, say, 6-9 months ago, but you should anticipate a little bit of a wait. Hopefully not as long as it's been here in the past. So that's pretty much the wait time on the Leo. All other scanners for Artec are available if you were interested in an EVA or a Spider, something like that. They are shipping those right now.
And that looks like all of our questions.
Okay. Well, feel free to reach out to us. We are, if you're interested in seeing a demo of your product or your scenario, we'd happy to do a customized demo for anyone involved. With that, thank you everyone for attending, and feel free to reach out to us if you have any questions. Thanks a lot.
Thank you very much.